Today we are working in Module 2, Lesson 4, and our objective is to convert numerical expressions into unit form as a mental strategy for multiplying multi-digit numbers. So you'll see we have the numerical expression 8 times 31, and I have what is the beginning of a tape diagram. So I am going to show 8 times 31 on my tape diagram. Now, I can look at the number 8 as a unit and say that I have 31 eights or 31 groups of 8 here. And so as I separate my tape diagram, I'm going to make a couple boxes. Okay, and I'm going to start labeling my boxes 8 because they are my unit. I have 31 eights. Now you'll notice that I don't have 31 boxes here. So what I can do is I can go ahead and make an ellipsis in this box here. And so that represents that my boxes are continuing, and I can assume that I would have 31 then. And just to ensure that I know that I have 31 boxes, I'm going to label my whole tape diagram as 31 eighths. Now, just having this tape diagram doesn't help me a whole lot. But I can look at this tape diagram and I can say that the number 31 is close to the number 30, and that 30 is an easier number to multiply by. So I can think about if I have 31 eighths in my top tape diagram, and I'll make a new tape diagram with 30 eighths, that bottom tape diagram is going to be 1/8 less than my top. So let me go ahead and make my bottom tape diagram here to show 30 eighths. And you'll see then how this is going to help me figure out what 31 eighths is equal to. So again, 8 is my unit, so I'm going to fill in my boxes with eighths. And I'm going to label this as 30 eighths this time. Okay, so now I have a tape diagram representing 31 eighths and a tape diagram representing 30 eighths. Now, when I look at 30 eighths, I see that there's a basic fact in there, 3. And so I can multiply 3 times 8. And I know that 3 times 8 is equal to 24. So that tells me that if 3 times 8 is equal to 24, then 8 times 30 is going to be equal to 240. So if we look at our tape diagram, we know that the bottom tape diagram is equal to 240. We have 30 eighths. Now remember, I said that my top tape diagram is 31 eighths, so it is 1/8 more. So to find the top tape diagram, I can take my 240, I can add one more 8 to it, and that gives me 248. So we have now solved 8 times 31 is 248. Now, of course, the idea is to do this to help us solve these mentally. The diagrams are going to help us do the multiplication in our heads, and so you may not see the work on your paper, you may not do the work on your paper as I've done on the screen, just to kind of show you what we're doing. Now we have a new numerical expression, and that is 49 times 20. So I'm going to use 20 as my unit. And instead of showing a tape diagram with 49 boxes, I think that I'm going to do 50 because 50 has that basic fact, 5 in it, 5 times 20, and that'll make it easier for me to solve 49 times 20. So I'll start with my tape diagram showing 50 20s. So again, I'll go through each of my boxes and I'll label them 20. That tells me that that is my unit. And I'll mark my whole diagram as 50 20s. So I can easily solve 50 20s in my head because I know that 5 times 2 is 10. So 5 times 20 would be 10 times that, so it would be 100. So 50 times 20 equals 1,000. And 49 20s is 120 less than 50. So I can take one of these away. And I can now solve in my head, what is 1,000 minus 20? Or if I need to, I can solve that on paper. Well, I know that 1,000 minus 20 equals 980. So I know that 49 times 20 equals 980. Now we have the numerical expression 101 times 12. This may seem a little more daunting because now we have a 3-digit number that we're multiplying by, but we're going to follow the same process using our tape diagrams, and we'll see that it's not any more difficult, really. So I went ahead and I made my tape diagram here, and I am going to use 12 as my unit, so I have 101 12s here. So I'll label each of my boxes with a 12, and remember at one point you're going to include your ellipsis because you're not actually going to make 101 boxes here. Now instead of drawing 2 boxes like I had done in our first numerical expression, I can represent 101 times 12 in this one box. Now I think that 100 is a more basic fact to multiply by, and that's going to make it easier for me to do this problem. So I'm going to show here in the first section of my tape diagram 100 12s. So then here in my last section, I'm going to show the leftover 112. So I can go ahead and solve 100 times 12. And I can think about my place value chart and multiplying by tens to help me solve this. So I know that 1 times 12 is 12. That means that 10 times 12 is 120. And that means that 100 times 12 would be 1,200. See how each time I multiplied by a number that increased 10 times, my answer also increased 10 times. Now I can see in my diagram here that I multiplied majority of my number. I multiplied 112s, and that gave me 1,200 or 1,200. Now I have 112 left over that I did not add in, so I need to add in that 112. So 1,200 plus 12 is 1,212. So I now know that 101 times 12 equals 1,212. And again, this was lesson 4 in module 2, and our objective was to convert our numerical expressions into unit form as a mental strategy for multiplying multi-digit numbers.